It's mailbag time with non-copyrighted music.
This mailbag is going to feature some older videos that I found with this old pink mat, and it's going to feature some new videos, some mail that I've opened just recently with the new green mat. So don't freak out, the colours will change, but it's the same guy in the same mailbag. Okay, this first one, this big one, it's not much of a mystery. Well, let's have a look. It's pretty clear what it is. Let's just say I've been doing a fair bit of 3D printing lately. And one of the things which alarmed me, though, was that the supplies sort of ran out for a while. So, yeah, global shortages affecting the humble filament. So that's not a good sign. This is PLA. And it's black, which is a pretty common colour that I use. I tend to use mostly white and black, so that's going to go straight to the vault for next time I need it. I just store it in a one of those big bins, those big buckets that you get from hardware stores, and I just throw in a heap of desiccant in there, or actually one of these guys. So, these are a couple of bucks from the dollar store. Should be called the $2 store, I guess. And you just tear the lid off and leave it there, and slowly over time it absorbs water. It's pretty good, and that keeps the PLA nice and crisp as well. Yep, so good get. This is quite light. Let's try this one. And we have. This guy's a bit interesting. So, I don't know where I came across this idea, but it has a USB output, or input, I should say, and then it's got this boost circuit in here. I'm not sure if it's buck and boost, and then an adapter so that you can run various projects. So, starting with 5 volts, maybe you could crank it up to 6 or something like that. I'm pretty keen to give this a try. Let's do it. All right, so we've gone with the old 220 ohm resistor in, looks like 1/2 watt. And on 9 volts, yep, no dramas. And on 12 volts, turns off pretty easy when you actually. It's a bit of a problem. It's the switches underneath, if you're wondering, and so when I lean on this, it just turns itself off like that. But yeah, 12 volts also no problem. All right, good. I think that's a little interesting. I mean, I probably prefer something which is tunable in that respect, but it works, and it may have its uses. Nice little boost converter there, coming from just a normal standard 5 volt USB outlet. Right, what is this guy? Okay, very good. Yes, so also for Raspberry Pi and for Orange Pi projects, getting good power to it is important. So these are 5 volt and 300 milliamp, and you just need the adapter for whatever project that you are using. A couple of AC to DC wall warts for those projects where they're needed. Nice one. Alrighty, let's try this side. And we have a couple of little cables. So yeah, we're just looking at the wall warts. Let's grab one of those out. And so then if you wanted, I think this is a USB, no, this is micro USB actually. Now that's interesting because I'm not sure I would have ordered micro USB. Maybe I did it. There's a lot of micro USB projects certainly I've got around the place, but I'm just finding that USB-C is more useful these days. But let's just try this one. So it just slots into here, and we are good to go. Yep, so a couple of these cables to go with these wall warts. Nice one. And this one is computer cables and connectors. Right. And it is indeed computer cables and connectors. So these are the particular type of adapters that work well with Orange Pis. So I think that's a 4mm and 1.7 adapter at one end, and of course you've got your ubiquitous USB at the other. So that is for your Orange Pi, of which I've got a couple floating around. So they need power. That's a good thing. This is quite light. Okay. Box within a package. Package within a box. And aha, yes, so more Raspberry Pi / Orange Pi shenanigans. And this is what we've got. Again, you know, basically to keep an eye on the puppies. We've got a nice wide angle, I think that camera is, and a couple of infrared lights here so we can see what's going on at night time as well. So yeah, curious to see how that will go when we plug it in and configure it. Nice one. Oh, it's a chunky monkey. What have we got? I can see them. All right. Still not sure. Heatsink. And Raspberry Pi fan. So yes, there's a few either Raspberry Pi or Orange Pi projects that I've got at the moment. For instance, Puppy Cam, which I'll link up here as well. And I've been using like external fans, but this is direct heatsink fans onto the chips themselves, and then you can put it in a box and plug this straight into your GPIOs on the Raspberry Pi or Orange Pi, and 5 volts and away you go. Let's test it. 5 volts coming in, and is it going to work? Yes, look at that. Ooh, pretty silent as well. Yeah, way better than the current solution that I've got. So yeah, definitely be swapping out the the great clunky 5-volt fans that I've got on the outside of the Raspberry Pi enclosures for something directly connected, as you can see there, to the chip itself, and some other little heat sinks to go along with it. So yeah, good one. What do we got? Let's have a look. Oh, okay. Some CMOS chips, I'm guessing. I know that I had a couple of orders of these from a long time ago. And what do we have? Turn this around so we can see it. Oh, it's upside down anyway, isn't it? So let's try it this way around. ULN2003A. So they are Darlington transistors, Darlington array. And yeah, the plan is with that is that I did do a little bit of work recently with a motor, a stepper motor, and a ULN2003 module. And the module had lots of LEDs on it, and that was probably lovely and everything like that. But I thought, I wonder if you could just feed the signal straight from the microcontroller through here and then onto the stepper motor. I think yes, but yeah, we'll see. And the other I see here is, looks also ULN-ish. What do we got? ULN2004. Not sure what the difference is. I'm assuming it might have something to do with the maximum current but I'll check the spec sheets. And yeah, very keen to, well, actually try both of these with the stepper motor and see if I can drive them directly from, well, not just any microcontroller, but specifically in the last video I was looking at the Paduk. So I'll run the same program through, and let's see if we can get that dancing motion happening again, but directly through a Darlington array rather than the transistor module like last time. Whoa, too big to fit in the shot. Strange parcel, this one. It seems like fluffy or something. We're just going pretty carefully from the side here. Let's see what we've got. It is a bit fluffy. Wow, okay. So, oh, right. Yes, I know exactly what this is. So, this is just to keep filament. Oh, there's a few things in here. Oh, okay. I didn't realise I'd ordered some other bits and pieces. All right, so this is all 3D printing. So let's start with desiccant, nice. Humidity monitors, also nice. Hot end replacement, should it be needed. And I've got a couple of these because I probably don't do as much maintenance as I need to do, let's just say that. So I have gone through one of these recently and replaced it. And also with the nozzles as well. So that's that. So I'll keep that separate. And this is something else. So this is just for keeping filament. It's a gift. These guys must have been watching my videos and they think, oh yeah, that guy really needs to groom his hands. And they'd be right. So thank you for the free gift. But this is these little packets. I guess you could put anything in them, but the idea is that you put some PLA and there's a valve there and you pump all the air out, and then that keeps your PLA, throw in some desiccant, keeps your PLA nice and moisture free. I'm going to put a reel in here and see how it goes. So this is how I normally store my filament. So in its original box, but not in its original cover. So this is just a little Ziploc bag. And then inside the Ziploc bag are some silica gel desiccant. So I guess the idea is that I replace that system with something that's vacuum packed. So, oh, in fact, this one has it been used? Yes, it has been used. So that's also a bag within a bag. So there's the filament. You can see it has been used. And then I'll put it back in its original bag with some desiccant and inside the Ziploc bag. So now the idea is, I guess, that I'm going to put it into one of these vacuum bags, put a little humidifier indicator in there. This is going to be embarrassing if it doesn't fit. Is it a slidey? No. All right, so let's open it up. Yeah, and put a little humidifier indicator in there. Well, that's quite a seal. And then pump the air out. And hopefully that'll keep everything nice and dry. Well, that is a good fit. All right, let's put some silica in there for fun. I did at one stage buy a heap of these little desiccants, but I tend to get them now. There is a lot of packaging, so I just collect them. Okay, so do not fill the bag beyond this line. All right, so I guess we put this back again. It seems sealed. And then the pump, I'm not sure how that's going to work. Air valve. Okay. Does that come off? I'm not sure how that works. Oh no. Seems to be, maybe it's just a one-way valve. No, I think that sticker needs to come off. So there's a bit of mucking around here and there to get the valve to work, but you know, that's pretty good. I mean, a lot of the air's missing from there. It's pretty tight. The desiccant's in there. Can't complain really. So that's just one extra layer of protection, and I'll probably put this inside a Ziploc bag, and then that goes in a storage container, and there ain't no air getting in there, which is a good thing.
That is the mailbag for the week, and we'll catch you next time. See ya.